Hello, it's Scott Manley here, and it's time for November's questions and answers from my supporters over at Patreon. But before we get there, I gotta stop for a second and say congratulations to Astra. Last night, I watched them launch their vehicle into orbit finally. LV0007, making it into a 500 kilometer polar orbit and therefore showing that they can actually start carrying some customer payloads, I hope. Look forward to seeing more of that. Myself, I'm actually going to be jumping in a car tomorrow, headed down to Central Coast so that I can actually watch the DART launch at Vandenberg on Tuesday night. Very happy with that. And of course, Thursday is Thanksgiving, and that means it's time for all the space nerds to watch Thanksgiving with the Krantzes again. And I have acquired a DVD copy, which I will release an upscaled version of it so you don't have to watch it in, I bleed 240p quality. Anyway, let's get down to the questions, right? We're going to start with Blanche. What is the lowest altitude a satellite using ESA's air-breathing ion thruster could orbit Mars? Could I hitch a ride if I was standing on the top of Olympus Mons? So, I did a video on this a couple of years ago. Normally, you wouldn't have satellites orbiting below like 250 kilometers because they decay very quickly. But ESA demonstrated an air-breathing ion thruster. And I think they talked about having satellites orbit below about 200 kilometers for a long time, using solar power and ion thrusters to maintain the orbit. Now, how does that compare to Olympus Mons? I don't honestly know because I don't carry these numbers around in my head, but I do know that there are clouds that are seen above Olympus Mons. And therefore, I suspect that the atmospheric pressure is probably more in the range between 50 and 100 kilometers of Earth. So this is probably still way denser than the atmosphere at which this ion thruster could operate. So I would say probably not. And could you actually hitch a ride? Given that it would be moving at hypersonic speeds, if you tried to hitch a ride, it would be disastrous for all involved. So don't do that. David Somm. Hi. How does the Falcon 9 core navigate when landing? Radar, GPS, optical? Thanks. It doesn't use thanks. It doesn't use wishes and prayers, but I do know that the trajectory is heavily managed by GPS data. Like, it is literally aiming for a spot in the ocean. And that is how it does most of it. Obviously, the barges are holding position based on GPS, and the booster is also using GPS for a lot of its descent. Now, I do also know that they use radar, and I think there was some. Basically, the Falcon Heavy has two boosters coming down, and they said at one point that they didn't want to have those coming down at the same time because it could interfere with the radar. So I think there's likely some ranging radar that goes on, although come to think of it, maybe that's on the landing pads. Anyway, radar is obviously an extremely helpful thing if you're trying to land it. And given that they were able to soft land it on the ocean, it must have radar on board because CRS-16, that went and spiraled down and landed in the ocean. So I think there must be radar on board. Okay, what are we seeing next? Hi, Scott. I have a question. Sorry, Jeff Anderson. I have a question that may be a bit of a challenge. As I understand, NASA generally frowns upon introducing organisms into an alien environment, also known as Mars, or any other planet, right? How will this change? Is it even being studied when we are looking to colonizing Mars? So, look, first of all, realize that Elon Musk saying that hypothetically we could colonize Mars in the next 10 years is entirely based upon the notion that you might have a spaceship that could carry people there. But there's so many other things to solve. This is not something that's happening anytime soon. It is a big question about when you start letting people, when you would allow people to go into places where they could potentially contaminate things. The thing is, Mars is very, very big, and I'm sure it can be coordinated in such a way that you can keep people away from the really sensitive areas. The real question is, like, if you do find that there is native life on Mars at some point, how much do you allow it to change? And can you then, is it fair for humans to come in and basically kill that off if that happens? There's a lot of questions that need to be asked. But yeah, when humans come, like, all bets are off, because You take spacecraft and you have to sterilize them, and you sterilize them by sticking them in ovens and subjecting them to radiation and all sorts of cleaning fluids and stuff. And you can't really do that with people. So you're just going to have to accept that human Earth bugs are going to get there. And truthfully, it's well understood that because of the nature of asteroid impacts, it's highly likely that debris from Earth has reached Mars. And if you do the math, it's entirely possible that those rocks could contain life that would make it there and potentially, contaminate Mars. Or vice versa. If life had evolved on Mars or Venus first, it could have reached Earth independently. Anyway, Daryl Nelson. Hi Scott, with the ISS being so big, how are they going to deorbit and let it burn up? Oh, yes. Well, guess who made a video about this a couple of weeks ago? Yeah, to deorbit the space station, the big problem is that it has low thrust, and you need to have as much thrust as possible so that you can actually drop its perigee deep enough inside the atmosphere to minimize the breakup area. And yeah, you're just going to bring it down in one big piece over an ocean as deep inside the atmosphere as possible. But watch the video, it has a lot more data on that. Mark Edward Towner. How exactly will Starship refuel? Butt to butt. What about the engines? Wouldn't a nose-to-nose connection make more sense? So I'll tell you why it's butt to butt, or why it was butt to butt. It's because, first of all, those big engines aren't needed when you're in orbit. They're primarily used for landing. They might be used for deorbiting, but they're not going to be used for very small maneuvers. So the bottom of the rocket, that's where you've got a whole bunch of plumbing already, so it would make some sense to put it there. However, I believe that Elon has since said that he prefers them docking back to back, and presumably this will be the steel side of the Starship, right? Not the tiles. You want to keep those from touching. But the bare steel side, I think they might dock. And the other problem with refueling. So let me tell you, transferring cryogenic propellants in space is not something that has been done at any real scale. And this is a huge problem that Starship has to solve. It's not against the laws of physics or anything. It's just something that hasn't been done and needs to be solved. Now, to maintain the propellant at the bottom of the tank so you can pump it, you have to generate thrust. And yeah, you can actually use small amounts of thrust to push it forwards while you're pumping the stuff across. I thought that the butt-to-butt thing actually made more sense, because then you would be transferring the fuel in the same direction, and it would, once you started it, in theory, it would push the vehicle in the right direction. But maybe things have changed. I don't know what'll happen. We'll see what the final version brings. But yeah, they have a problem that they need to solve. And first of all, they've got to get to orbit. Connor N. Hi Scott, big fan. What are your thoughts on Blue Origin's New Glenn rocket when compared with the other heavy lift vehicles? So New Glenn is a monster of a rocket, right? It is definitely comparable to the Falcon Heavy in terms of the amount of mass it can get to orbit. Obviously, let's be clear. Hypothetically, if it exists, the only thing we've seen is a Pathfinder first stage, which has been rolling around Kennedy Space Center to make sure it can manage all the roads. This is not a real booster by any means. This is something that is roughly the right shape and size and mass. But what we have seen, though, one of the very first things they showed from New Glenn was the fairings. And the fairings on this are significantly larger than those on the Falcon Heavy. That is one thing where New Glenn can certainly claim to be a bit of a step above what SpaceX is offering in terms of payload volume. Of course, that's in a world where Falcon Heavy is the heaviest lift vehicle that SpaceX offers. Yeah, look, the thing about New Glenn is that it's a largely unproven launch vehicle, even when it does come out. And so it's going to be competing against Falcon Heavy and Vulcan, which presumably at that point will have been flying longer and will have the same engines, except it'll have a different second stage. So in theory, offering bigger loads it might be able to do stuff that Vulcan can't. It might be able to do certain large low density payloads that Falcon Heavy can't. And look, Blue Origin have partnerships which may result in them getting payloads that the other ones don't want to look at. I don't know. It is a monster rocket. It's very capable. I would like to actually see it flying. That's what I would like to see. Tesla Rob. Hi Scott, how do they get solid rockets into the proper orbital injection? Since they can't be throttled or shut off, do they just carefully measure the exact amount of propellant needed? Okay, so you can actually see this in action in the Antares launch vehicle. So the Antares, the first stage, is a Ukrainian first stage with Russian rocket engines and an American second stage and a European Cygnus design. Like the Cygnus is basically derived from a European design. But the second stage is basically a solid rocket motor. And what they do is once that gets up into space, is when it starts light firing the motor, it fires slightly off axis, so you get cosine losses. Because it's not firing exactly along the velocity vector, it doesn't deliver 100% of its thrust in the direction, to accelerate along its orbit. So they can do this by carefully planning their trajectory to make sure that when the thing burns out, it has generated exactly the amount of delta V they need to get it into orbit, and then, they can clean up any residuals with the propulsion on the Cygnus. But because Cygnus is a cargo spacecraft and it can get loaded up with a whole range of cargo, they can't rely on NASA loading exactly the right amount of cargo so that they can just firing the thing and get maximum delta V. So they need to control their delta V. And if you look at the thing, you'll see that they've adjusted their angle to make sure that they reduce the amount of delta V that they get to exactly what they need. Troy Schmidt. Wait, Mr. Manley, I can't help but wonder, have you been watching Ibix Toy Cat? I've no idea what that is. Next. Alan. Hi Scott, given how dangerous hydrazine and nitrogen tetroxide are, why is no one, apart from interorbital systems, which are, I know who those are, using less hazardous hypergolic combinations like turpentine or furfuryl alcohol with WFNA, which is white fuming nitric acid, which I wouldn't consider less hazardous. I mean, it's still pretty hazardous. It's less hazardous than some things, but it's still pretty hazardous. Is the loss of performance that great with the safer combinations? I just don't think they're that much safer, to be honest. It's a whole lot easier to spend your money and time to learn to use kerosene and liquid oxygen on the ground, or to use existing propellants in space. There are green monopropellants. There are people that are looking at these monopropellants. The other thing I think actually is that for ground launches, things like furfuryl alcohol and white fuming nitric acid, they have fairly long established amount of testing behind them. Not sure that they have that for space. I'm not sure that they have the necessary temperature range to make them work. So it's not clear. Basically, it's very hard to argue against aerospace inertia. There are better propellants now in the monopropellant category than hydrazine. There are some very cool monopropellants that are basically non-toxic, or at least sufficiently non-toxic. You don't need a hazmat suit. But they haven't seen adoption yet because they're waiting for people to use them enough that they have a good history behind them to analyze them. I think it is largely inertia. And if you're talking about ground systems, kerosene and liquid oxygen, or hydrazine and liquid oxygen, or methane, those seem to be so much easier now to work with, and especially to get past environmental things on the ground. You have all your paperwork already planned out. That's another thing. It's having a history means that somebody's already done the paperwork previously, and you can point to them as your reference point. Andrew Waite. On the 10th of August 2021, ESA's Bepi Colombo spacecraft made its second fly of Venus, to be followed by 1st of October 2021, its first flyby of Mercury. Is this fastest transit between two planets by a spacecraft? That's a good question. Well, I think Lucy has a month between two of its targets. So if you define planets as minor planets, I think Lucy is going to fly between two things in about a month apart. And the other one, so this has to be going very fast. So the objects have to be close together like they would be in a Lagrange point, in the Trojan point, or it has to be the inner solar system. And the only other missions I can think of that have been zipping through the inner solar system are Messenger, which I think it was mostly Venus and Mercury fly past, but Parker Solar Probe. Now, almost all of its encounters have been with Venus, right? The Venus is just the one it keeps hitting. But I know that it launched from Earth and very quickly made it to Venus. I think it was like the fastest transit from Earth to a target planet. But I don't know if that's faster than the time between your Bepi Colombo between those two targets. Somebody go and Google it and put it in the comments. Wookie Goldberg. Hi, I understand how the expansion ratio of a rocket nozzle is determined by the area and thus the radius of the nozzle's throat and exit. What determines the axial distance between the throat and the exit? Right, so why is a nozzle? So we know that, if you want to go from the throat to the nozzle, you have them a certain size. And what he's asking, I presume it's a he, why is this, here, and why isn't it like a short stubby nozzle that expands this much, or a long thin nozzle that expands like that? So basically nozzle contour shape is one of these things that's been arrived at through a whole lot of engineering and testing, and there's no one perfect shape, but I remember reading somewhere that there's a trick where if you expand it quickly early on, you get these sort of decompression shocks, right? And then as it curves inwards, you get compression shocks. And a good, well-designed nozzle will actually have these shock waves sort of intersect and cancel each other out. I remember reading something like that, but it's something that's basically been reached by lots of trial and error and modeling and things like that. So yeah, the shape is largely constrained by making sure the conditions inside the nozzle are what you want, but there's no hard and fast rule. If you expand it too quickly, you do get these decompression shocks that mean you lose energy. And if you do it too slowly, you can also apparently lose energy by that. But also if you're making it really long, you're making a really big and heavy nozzle. So what I'm saying is, I don't have nearly enough academic credentials or experience to answer this question, and this is a rough guess, but boy, something I'm going to have to learn one of these days, huh? Okay, John Sullivan. How rare is life in the universe, in your opinion? Wow, from something I'm not qualified to talk about to something that I'm really not qualified to talk about. So, look, my opinion on life in the universe is big. Life is out there. How common is it? That's a really hard thing to say, because on Earth, practically everywhere we've looked, well, except for actual molten lava, right? Practically everywhere we look, we find life. We find it at the bottom of the oceans, we find it high up in the sky, we find it in rocks that are miles underground. Life, once it gets a foothold, evolves and fills every single niche it can get its hands on. Now, how common is it in the universe? That is a totally different question that I'm not equipped to answer. This is one of those great questions for our time, and I don't have a good answer. I would like to believe that if you give it enough time, life will emerge under the right conditions. It could be that we find life on Enceladus and Europa and Callisto, all these other places out there where there is water underneath and there's an energy source. It could be there's life on Mars. It could be we find that there was life on Venus and it's now no longer there. Or even worse, Venus life has evolved and survived and is now really dangerous. Yeah, that's a question that is beyond me. Finally, Andy Longhurst. How much force would be required to blow up the moon? And if you had to do it, how would I go about doing it? That's a good question. Well, you say how much force. It's not really force we're talking about, it's energy. And I remember doing the math on blowing up the planet Earth. And it turns out it takes about 1 week of solar luminosity to you put enough energy into the Earth to spread it out so it will never come back together again. Now, the amount of energy taken to dismantle a sphere is, or the like potential energy to create, or you release by creating the sphere, is proportional to the mass squared and inversely proportional to the radius. So the moon is like 81 times less massive than the Earth, and it's about 1/4 of the radius. Wow. Yeah, we're talking like maybe an hour of solar luminosity to destroy the moon. Now, how would I go about it? Well, obviously, a big magnifying glass sounds like a good option right now. Now, if you're going to destroy the moon, the cheapest and easiest way to destroy the moon is to crash it into the Earth, obviously. Right? But if you don't want to destroy the Earth, then you have to figure out some way to hit it very hard with something. Yes, there's my answer. Crash it into the Earth. And therein is a trailer for a movie called Moonfall, right? It's gonna be a terrible movie. Anyway, yes, I have to now turn this into a video with diagrams and stuff and send it out to you while I'm on the road down to Vandenberg. So I will see you in a few days. I'm Scott Manley. Fly safe.